All right, good afternoon, statistics. So what I'd like to do today is to give you a chance to practice some more with the probabilities from the normal distribution, calculating them using your calculator, but also kind of reasoning with them using the empirical rule as well. So what you've got here is a video that's going to show you a couple more examples, showing you what it's like to draw it out and to calculate it. And then what I'd like you to do after this is to go ahead and use or do the practice worksheet that I have left with the sub, just to make sure you are feeling really solid with this material. Okay, so this would have been the bell work had I been here today. So let's go ahead and talk through it. So describe the difference between an N12-2 and an N12-15. So obviously we can see that the difference is that there's a 12 and a 15, right? So remember that these numbers represent the standard deviation. So if this one has a larger standard deviation than this one, that means this one's going to be more spread out. It's going to be low and wide. This one's going to be more tall and narrow. Okay. Since they have the same mean, though, that means they are centered above the same number. So like if I were to draw my line right there, which is nice and jagged. So this number perhaps is 12. Okay. So maybe the N12-2 would be really tall like that. Okay, and the N12-15 would be really low, like that. So this one would be the N12-2. This one would be the N12-15. Okay. All right, let's try another one. So demonstrate how much each data occurs in given boxes by filling in the boxes with one of the following numbers: 2, 12.5, or 34%. So we look at this normal distribution, and this is all based on the empirical rule, because look at this. This is actually between +1 and -1 standard deviations, which we know from here to here should be 68%. Okay, which means if I divide that in half, from here to here, there's 34% of my data, and from here to here, there's 34% of my data. Pretty cool. Okay. If I move one further out, I know from here to here, 2 standard deviations away from the mean, I have 95% of my data. Well, 68% of it's already being taken care of in here. So then if I divide the remaining between these two boxes, that should be 13.5 and 13.5. And then last but not least, from here to here, I know I've got 99.7% of my data. And so rounding just a little bit, that means 2% of my data should fall out there. So between all of these percentages, okay, I know exactly how much is falling between each standard deviation. Okay, and as we do more stuff with calculating probabilities, I hope you find that this empirical rule is confirmed over and over again. Okay, all right. So first problem that I'd like to try. According to data from the College Board, the mean quantitative SAT score for male college-bound high school seniors in 2009 was a 530. Assume that SAT scores are approximately normally distributed with a population standard deviation of 100. So hopefully you've seen two important pieces of information. That's the mean. That's the standard deviation. If a male college-bound senior is selected at random, what's the probability that he would score higher than a 675? So maybe this is a scholarship committee or something like that, and they're trying to decide where to put their SAT cutoff score at. And so they want to know how many people they could expect to apply for a scholarship that requires a 675. Well, we know we're talking about a normal distribution with a mean of 530 and a standard deviation of 100. Okay, and so when I put it into my calculator, you're going to grab the normal CDF, and I need to know my bottom range and my upper range. Okay, this is why I always recommend drawing that picture, because it's going to help a lot. Because if I know my mean is 530, that means that I'm looking at the score of 675 or higher. So I'm looking at this region up here. So based on my shading, I can see the bottom of my region, the lower value is going to be 675. My upper value is a very large number, so I'm going to go with like 10,000 just to make sure it's nice and big. Okay. And then I need my mean and my standard deviation. So 530 is my mean. 100 is my standard deviation. Okay. Go ahead and plug this into your calculator and see what you get. All right, once you put that into your calculator, you should have gotten 0.0735. Okay, so round that off to maybe 0.07. That means we're talking about approximately a 7% chance that someone would score higher than a 675. So that scholarship committee, let's say, is looking at this, they would only have 7% of high school senior males that would qualify for this scholarship. There may not be too many, but we'll leave that up to them. And if you look at your diagram, you can see my answer is pretty reasonable. I was looking for a fairly small percentage. It's not going to be a lot. Okay, let's try this one. According to the Centers for Disease Control, the CDC, 3-year-old boys have a mean height of 3-year-old boys have a mean height of 38 inches and a standard deviation of 2 inches. The distribution is approximately normal, okay? And just so you know, you guys have been on these charts ever since you were born. Your parents take you to your doctor's visits and stuff when you're younger, and they measure your height and your weight. All of those charts are based on normal distributions. That 68% of the population falls within a certain range of heights and weights and stuff, and then everyone else is kind of spread out from there. Okay. So how many 3-year-old boys would we expect to be 39 inches or taller? Well, let's look at our normal distribution. The mean is 38, so that's going to be right here. Okay, so 39 is not that much taller than that. So here's 39. And I'm looking for those who are 39 or taller. So it's going to be all the ones out here. Okay. So if I go to my calculator, it'll be normal CDF. I need the lower end of my range, so that's going to be 39. I'm going to need the upper end of my range, so that's going to be up here. So a very large number, maybe go for 1,000 or 10,000. Okay. And then I need my mean, which would be 38. And my standard deviation, which is 2. Okay, so go into your calculator. Just a quick reminder, if you're not following where normal CDF is, you go to second, and then right underneath the arrow keys on a calculator, there's this button called VARS, V-A-R-S. If you hit that, then there should be a normal CDF that you can choose from there. Okay, so plug in all of your numbers. And I come out with 0.3085. So round that up to 0.31. So approximately 31%. And looking at this, yeah, I could go with that, 31%. We definitely know that this should have been a bigger percentage than the one on the previous page. And we did come up with one. Okay. All right, so same situation. What percentage of 3-year-old boys have a height of 38 inches or more? Take a look at the normal distribution. The mean is 38. And I'm wanting to know what percentage will have a height of 38 or more. So even before you do this calculation in your calculator, what are you expecting? If I ask you how many people have a height of the mean, the average or more, what would you expect? Yeah, if you're thinking something along the lines of like 50% or half of the people, I think you're on the right track. Let's go ahead and do that on our calculators just to confirm. So normal CDF, the lower end of my range is 38. The upper end is a really large number. And then my mean is 38 and my standard deviation is 2. Okay. Go ahead and plug that into your calculator. 38, 10,000. So my calculator says 0.4999 repeating, which would round up to 0.5. There you go, 50%. So we can expect 50% of those boys to be 38 inches or taller. Okay, let's try this one out. So in a standardized test with a normal distribution of scores, the mean is 63 and the standard deviation is 5. Which score can we expect to occur most often? And here's my answer choices. Okay, so this one I'm not even really doing a probability calculation. I'm just going to kind of look at these and decide which one's going to occur most often. Okay, if we know the mean is 63, take a look at my normal distribution. We know that things that occur most often will occur close to the mean, right? Okay. Which of these numbers is closest to the mean? Oh, yeah. Take a look at our 65 here. It's only going to be just 2 numbers above the mean, which, if the standard deviation is 5, means we are within the first standard deviation, right, into this area. So I think 65 is probably the closest to the mean, which means we can expect most often to have the score of 65 occur. Okay? All right, so right now what I'd like you to do, go ahead and do the normal probabilities practice. Okay, it's only 4 questions, I believe. There is an answer key if you need to check your answers when you're done. Okay. After that, please work on your homework. You should be able to do numbers 1 through 9 now, okay, which is a good majority of the packet. All right. If you are done before the end of the hour, please find something else productive to work on, okay? And so by productive, I mean something for school, okay? If you can't find something productive to work on, then I would recommend going to Khan Academy and working on something there. All right. Have a fabulous weekend. Work hard, and I will see you on Monday.